Welcome back. In this video, we are going to see what's a polynomial, how do we represent a polynomial in structure, and how we can add two polynomials. Okay, so let us see the first one, which is what is a polynomial. Everyone knows what's a polynomial, so which is nothing but sum of terms where we have uh, coefficients and exponents. If you look at the polynomial which you can see on the screen, the first one is a of x 3 x to the power 20 plus 2 x to the power 4 plus 4. So 3, 2 and 4 are the coefficients and 25 are the exponents. You can see other one. You should take it as x to the power 4 it is, and this is going to be x to the power 3. This is x to the power 2 and this is x to the power 3. So these are the exponent, and x I can take it as 1x, this is 10x and 3x. These are the coefficients. So normally we write the polynomial with the largest or leading exponent of a polynomial as is a degree of the polynomial. If you look at the first polynomial, we can say that degree 4, this is going to be 20 because this is going to be the largest exponent. So let us see how we can represent polynomial. Normally we used to take a structure which is a type defined structure. As everyone knows, every polynomial is having two parts. One is coefficient, other one is exponent. So we have taken a structure with two members. So we have coefficient and exponent, and polynomial is a new type which I have created. So remember that polynomial is a new type I have created, and using this type, look at this. Using this type, I've created a variable called terms. I'm not creating a single term. I'm creating a term of arrays. How many terms I'm going to create? I'm creating 100 terms. 100 terms. So next, so I'll take two polynomial for this. So first one is my a of x. A of x. This is the coefficient for this. Coefficient part I just stored 2, and exponent part I stored what is the exponent for this, and this I'll mark it as start a. So for this start a, and for the next one, so we have no exponent part for this. I'll just write it as 0, and the coefficient is going to be 1. So I'm done with the first polynomial. So the start a tells you where the a starts, and finishes says where the polynomial gets over. Same way with b, you can see b also have the first one is the coefficient is going to be 1, and the exponent for this is going to be 4. I'll just return this. And for the next one, coefficient is 10, exponent is 3, then 3, and the exponent part is 0, and the last term it is 1. 1 is the coefficient and exponent is going to be 0. So I've done it. So after that, what I do is I'll have a variable which is going to give you the availing address of the next term which is available. So this is a way we represent the polynomial. Now let us see how we can add two polynomials. Okay, so how do we add? So we take the first term of the first polynomial, compare it with the first term of second polynomial, and if their exponent value is same, so please remember, if their exponent values are same, we can add it. Otherwise, first you have to check whether their exponent value is same. If it is same, we are going to add the coefficients. Otherwise, if a's exponent value is greater than b's exponent value, so we are going to write the term in a as the resultant polynomial first term. In case a is lesser than b's exponent value, so we are going to give up a, we'll go to b, we are going to take the term in b and put it in the resultant polynomial, right? So let us see how this is done. So we have taken, yeah, so we have taken two polynomial. So please take care of the polynomial. We have taken very simple polynomial. One is a, other one is b, 2x to the power 100 and 1. The first polynomial is having only two terms, 2, and the coefficient for this coefficient is 2 and exponent is 100, and for second term it is 1 and 0. So this is start A and finish A. And for second one, start B, which is having coefficient 1 and exponent is 4, and which ends here. Okay, now let us trace how does it work. So we have taken a function called p add, so which is having many variables. Start A, we should know where A get finished, we should know where B starts, we should know where B finish, and we have taken another term called D. This is for the resultant polynomial, where D starts and where D ends, right? Yeah. So let us uh, start. So start is equal to avail. So this is going to be the resultant polynomial. We call it as D. Fine. Next, start A is less than or equal to finish A. You should check the condition does not reach the end of the first polynomial. If it is true, and what is second case? Start B is lesser than or equal to finish B. It has not completed the second polynomial. If two cases are okay, what you are going to do is you are going to compare it. What is the comparison? So terms start A dot exponent. You are going to compare the exponent value of start A and B's exponent value. Where is B? So when I compare it, I'll have three cases. One is either A's exponent value can be greater than B's exponent value or equal to the last cases, which it can be lesser. So if case 1 says A exponent is lesser than B's exponent. So if you take this case, A's exponent value is greater than B's exponent. So it will not come to this case. Second case is case 0, coefficient. If A's exponent value is equal to B's exponent value, in this case what happens? A's exponent value is not equal to B's exponent value. I cannot do it. So it will come to the case 1. So what is the case 1? A's exponent value is greater than B's exponent value. If that's the case, what you do is attach terms, start a coefficient and start a exponent to the attach function. So we are going to attach this function in the resultant point. How it is attached, we have to see later. So this will be done. After this, you are going to increment A. Now what happened? Your A is, this is going to be your A. You have attached this. The first term of the first polynomial gets attached to the resultant polynomial. We'll compare this. Again, now where is start A? Start A is going to be here. So next again you are going to compare it whether start A is lesser than or equal to finish A. Yeah, in this case it is equal. And whether start B lesser than or equal to finish B. Yes. Start B remains in the same place and finish B is over here. So again this condition is true. Now case before the case you have to check compare terms start A exponent. What is exponent for this? Which is 0. And B's exponent. What is B's exponent? Which is 4. So when you compare 0 and 4, it is understood that 0 is lesser than 4. So when A's exponent is lesser than B's exponent, what I have to do? I have to write this B's term into the resultant polynomial. So this is what I'll attach term B into the resultant polynomial, which is going to taken care by the attach function, and you have to increment your B. Now we are done with this B. So I'll increment start B to this. I'll continue. How long I should continue? I'll continue till everything is done. And it looks very simple. And this is the way we are going to add two polynomials.